Tonight's homework is composed entirely of SAT test preparation problems involving probability and combinatorics. So it's very challenging. Some problems are easier than others. I just want you to know that when I grade a homework like this, I take that into account, that this is very challenging. So don't stress out. Just do your best to show your work. And I'm going to do what I believe is the hardest of the 6 problems. Number 5, it gave me some trouble until I realized something. So if the 5 cards shown are placed in a row, so that this should say cards, so that cards B and C must be next to each other, how many different arrangements are possible? So if cards B and C must be next to each other, we could put them first, and then we could put A, D, E like this. That's one arrangement. Or we could put B and C first, and we could put D, A, E. That's another arrangement. But really don't need to do every single one. That's going to take forever. We just have to realize that if B and C are first, these other 3 cards are 3 items being arranged where the order matters. So that's a permutation of 3 items taken 3 at a time, which you could do the whole permutation formula, but it simplifies to 3 factorial. And 3 factorial is 3 times 2 times 1. So there's 6 arrangements here where the BC card is first. But I could also have the BC card be in this position. I say card because if B and C have to be next to each other, you could think of them as a single card. And then I could have the other 3 in these positions. And then again, we would have 3 factorial, or 6 ways to arrange the cards. Or you could have BC here with the other 3 cards like this. That's 6 more ways. Or you could have the BC card at the end, and that would give you 6 more ways, for a total of 24 possible arrangements. But there's a little bit more to it than that. Why don't you think about that during the pause and see if you can figure out why 24 is not the correct answer to this problem.
Paused.
While B and C need to move together, there's nothing saying that it couldn't be this way, CB. The C could be before the B, and B and C would still be next to each other, so you have to double this 24 for a total of 48. There's another way to approach this problem. Since the BC card have to move together, you could think of it as the arrangement of 4 items taken 4 at a time where the order matters, and you can just do 4 factorial, which is 24. 24, and then you double that to account for the fact that it could be CB instead of BC. And so the answer to problem 5 is 48. I want to look at, I'm not going to do all of problem 6, but I want to look at it briefly. We should have done a problem similar to this in the problem solving we did in class today. I just want you to know that, well, let's read it first. Set A are the integers 0, 1, 2, 3, or the whole numbers 0, 1, 2, 3. Set B are the whole numbers 4, 5, and 6. If A is any element from set A, so A could be 0, 1, 2, or 3, and B is any element from set B, so B could be 4, 5, or 6, how many different values are possible for this fraction A over B? So your numerator is going to come from set A, your denominator is going to come from set B. I don't think there's, it could be wrong, but I don't think there's any easier way of doing this than creating a tree diagram. So your numerator, the choices for numerator are 0, 1, 2, 3. If 0 is your numerator, your denominator could be 4, 5, or 6. And I think you really want to look at the sample space to see that 0 over 4, that would equal 0, 0 over 5 equals 0. You really need to look at what each of these fractions, what their value would be once you simplify them. Because it's not asking for how many different fractions you can make, it's asking for how many different values are possible. So it's not as simple as 4 multiplied by 3 or 12. You have to see how many values are repeated and not include them when you're counting. Okay, I hope that helped with